Hello, ladies and gentlemen, Marsh here. So today we're going to talk about strings. What are they? How are they used in Java? And some methods that are going to be used for strings. So first things, remember that strings are an object. They have a reference variable attached to them. Unlike other variables and objects, they're also immutable. Now, immutable means they cannot be changed. Now, you're probably thinking, well, Marsh, that's very unhelpful. Strings can be changed, but it's kind of strange how it happens. So in this term of immutable, let me change my color to black here so it's easier to see. Okay, so let's say I make a string. Let's call it greeting. Okay, so right here, what happens if I would write string greeting equals hello. Let's say I declare and make it say hello. So what's going to happen is for that string, it's going to make a reference variable named greeting, which is going to point in the memory to a box that says hello. Okay, so all this has is a reference variable. This says where the location is of hello in the memory. Now, what do I mean by immutable? What happens is if I would somehow change greeting to something else, let's say instead of hello, maybe we're going to change it to hi for the greeting. So what's going to happen is hi will be created right here. Okay. And the reference variable is no longer going to point at hello. It's going to point at hi. Hello, the variable, the actual where the pointer object was pointing to, does not change its value. That stays here. This is going to be collected by the garbage because it is collected, being that there's nothing pointing at it. It is an object an object that has nothing pointing to it. So now hi is pointed. Now, what could also happen is let's say I make another string called greet, and I also assign that to be hi. Okay, so what's going to happen is in memory, another reference variable named greet will be created, stores the location, and what it's going to do is also point to the same exact reference as greeting. Now, you're probably thinking, could that cause a problem? What if I would make greet now to be hello? Will that change greeting? It won't, okay? Since greet is all you're changing, you are not going to change greeting as well, even though they're pointing at the same thing. Because what greet's going to do is it's going to change its location pointer. It's going to say, yes, I got to point to hello now, because that's what you made it point to. So something to keep in mind with strings is that once you change the value of the string, that value that was originally there is still somewhere in the memory of the program. Does this change a lot for you? No. However, it just gives us an idea that this object, these strings, they are unchangeable in the regards of you are not actually changing the actual object. You're just pointing at a different one. Now, there's a couple of other things about strings that we're going to talk about. There is concatenation, which is a fun word. It means to put two strings together and to form one string. So in Java, the concatenation operator is the plus sign. So right here. So I have string equals hello, string nx equals good buddy, and string c is plus nx. So what I am doing is I am taking and I'm adding an x to it. So what's C? So this is C right here. He's going to point to a new spot in memory that's going to say hello and good buddy. Now notice there's no space here, no space there. So what's going to happen is we're actually going to print hello, good buddy without, or not print, excuse me. We're going to store hello, good buddy, but no space between hello and good buddy. So the plus operator is concatenating these two strings together. It's adding them together to form one string. What I'm doing then is I'm going to print out C. So I will print out hello, good buddy without a space between hello and good. So all concatenation does is just adds the two strings together, lets you put stuff together. Now, there's several methods that we want as a programmer to use. We have what's known as the length method. The length method returns the number of characters in the string. So I can go string the name equals Donald Duck, int len equals the name dot length. Now notice you always have to call the string then place dot length. You can't just say dot length. You need to have an operator. You need to know what string do you want the length of, okay? So the name dot length, what that's going to do is count the number of characters. So how many characters in the name? Well, 1, 2, 3, 4, 5, 6, 7. Don't forget that space. 8, 9, 10, and 11. So len will get a store value of 11, and I will print out the number 11 to my console. So keep that in mind. Length is how many characters there are in the string you're looking at. And here's kind of where a lot of students get struggled. Now, there are such a things called indices of a string, which means that basically the spots in the string, we're going to start counting at 0, and it's going to end at the string.length minus 1. So W would be in the 0 spot, the 0th spot. We start counting at 0 in programming. 1 would be for I, 2, 3, 4, and 5. Now, the length of this string is 6, right? 1, 2, 3, 4, 5, 6. The last index of this string, however, is its length minus 1, aka 5. That's always going to be a good thing to keep in mind. The last character of a string is length minus 1. Okay, and a lot of times that's going to be very useful, especially as we get to what's known as loops or iteration through strings. Another method that's super useful is called IndexOf. What this does is it returns the index of a string inside of another string. Now you're like, that sounds odd, but let's look at some code here. So I got string the name equals Donald Duck. Okay. Int index equals the name dot index of. So I'm saying this string, I want index of the word on. So I'm looking for the first instance of on in Donald Duck. So index meaning where does it start? So again, remember we start at 0. So I'm going to label all my letters here. 1, 2, 3, 4, 5, 6, 7, 8. Whoop, I missed the space. Just kidding. That would not have been good. 7, 8, 9, and 10. Okay, so Donald Duck is 11, but the last index is 10. And they want to know, when does on show up? Well, on shows up at index 1. So index would have a value of 1 when I print it out. Now, you're probably thinking, well, what if I try to find the index of something that's not in the word? So let's say we tried to find the index of X inside of the name. Well, that's not present, right? X doesn't show up. If the string is not present, you will get a -1. Okay, so if I said the name dot index of X, I would return a -1 to index. Index would have a -1 in it. So -1 is Java's way of saying, you know what, I couldn't find it, so here's a value anyway. They can't return 0 because that would mean that's the first letter. Can't do that. So they return a -1, something that doesn't make sense for indices. Okay? Another one that's kind of useful is the idea of a charAt. This returns the character at a very specific index you asked for. So again, I got string, the name equals Donald Duck, char letter, the name, dot charAt 4. Okay, so I want to know what's the char in the name at index 4. So again, I'm going to go 0, 1, 2, 3, 4. So it looks like char, the char letter, will be storing an L. And thus I would print out an L. So charAt allows you to get a very specific character at a specific index, and you need to know the number of index that you want. Now, substring. Substring has 2 versions, and each provides a piece of a string that is provided. So I got string my pet equals Sparky the dog. And I want to get my pet dot substring 4, 12. What this will do is it will give me a piece of my string. It's a sub of the string, a piece of the string. Starting at index 4 and going to index 12, but not including 12. So for those of you that have taken upper level math, I would say it's a bracket on 4 and a parenthesis on 12, okay? This is the way that I would represent this. The way I always think is I start at 4 and I go to 12, but not take that index. So let's find out what small part would be assigned. So I got to find index 4. Okay, that's starting at K, right? So now I got to get to 12. So 5, 6, 7, 8, 9, 10, 11, 12. Now we're going up to 12, but not including. So we're going to cut off at 12. So small part would print inside my print line KY space the D. Okay. Now, there is a second version of substring that looks a little different. So again, I got Sparky the dog, my pet, dot substring 4. Notice, only one number. When you only have a single number, this is saying where to start and you're going to go to the end. So if you have one number, you start here, go to the end. So 0, 1, 2, 3, 4. I'm going to start at K, and I'm going to completely go to the end. So I would print KY the dog. Okay. So if you have one number, that tells you where to start, and then you go to the end of the string. If you have 2 numbers, that tells you when to start and where to end. Substring is very useful. Let's say the user types in their full name, such as John Smith, and I just wanted his last name. I could take from the S to the end to find his last name. Then you got another method called replace all. So it returns a string replacing all the instances of a certain string with another string. I know that's a lot of strings. Here's what it does. So I got string phrase, Peter Piper picked a pack of pickled peppers, and I'm going to replace all the lowercase p's with t's. So let's think here. Well, this p would be changed, right? This t would be changed. This t would be changed. This t, this t, this t, and that t, right? Notice the capital P on Peter would not change because we're only changing lowercase p's. So my new phrase would be Peter Pitter ticked a tack of tickled tetters is what I would print out. Okay, so all replace all does is just takes whatever you're looking for and what you want to put in that spot. You could put, like, let's say we wanted to do What would work here? Maybe we want to find CKs. You could find multiple letters and put a letter in its spot. You could just take one letter, the P, and you could have put marsh right here. And every time there would have been a P, you would have put marsh instead. So stuff like that you can use it for longer than just a single letter. You can use it for like big word that you're looking for and you want to replace. Another option to do, it's not used very often. However, sometimes maybe if we need to clean something from a user that they typed in, it eliminates all your leading, trailing, and spaces. That's the trim method. So right here, I got string input, lots of spaces, Billy Bob, lots of spaces. I go input.trim into input. So notice what's happening here is I am trimming input and placing it back into input, and I will print out just Billy Bob. Notice the space in the middle of Billy and Bob is intact. It only takes care of the ones in the front and the back in that regard. Now, here's the thing. I could not just go input.trim, okay, without the equal sign like this one has, because what would happen is it would trim input, but then it wouldn't assign it anything. This would just trim it, but it wouldn't give it back into the variable input. So I always have to, whenever you're doing this, anything with strings, make sure you assign it back to somewhere. Either A, creating a new variable, or maybe you want to overwrite the old information. Make sure when you're doing that, make sure to overwrite or give it a spot to put it. Because otherwise, Java's going to do his job. He's going to hold it out to you like, here you go, I did what you asked. And then if you don't give him a box to put it in, he's going to throw it away. And you don't want that to happen if you want that information. One other one that's on here is toUpperCase and toLowerCase. So this is going to return a string with all uppercase letters or all lowercase letters. So I got username equals user123. I say username dot toLowerCase. That's going to give you, well, user123, all in lowercase. Now, if I wanted to do toUpperCase, I could go toUpperCase, and then it would do the same thing. This in this case, it wouldn't work. This is very useful if you're not sure when you're trying to compare letters, strings. Let's say someone decides to type a capital letter for their name, and then the next person decides to do all lowercase. Maybe the next person decides to go capital, lowercase, and we need to compare. We need to have that ability to change everything to something that's easy to read. Again, notice I did assign it back to username after I did it. If this left-hand side was not here, what would happen is I would change username to lowercase, but then I wouldn't store it back. Keep in mind, whenever you're changing something, make sure that you store it somewhere if you need that data. And the second to last method we're going to talk about is the compare to method. It's going to return an integer based on comparison alphabetically. So string A equals Bob, and I got A dot compare to alpha. What's going to happen is it's going to compare Bob to alpha. If Bob is greater than alpha, I will return a positive number, aka telling us that Bob comes after alpha. Okay? If S1 would have been less than S2, so like let's say this would have been, let's go AH. That would, so if I would say that instead of this, I would put AH, okay, and I would compare it. That would mean it's less than, so I would return a negative number. This is saying that this guy is smaller than that guy. If you would get them to be equal to one another, so this would also be alpha, it would return 0 saying, hey, this is the same thing. This is useful when we start comparing strings and we want to put them into order with one another. So maybe you get a bunch of words and the person's like, put them in order, and you're like, okay, I got this. Okay, so that's useful in that regard. We also have the ability to do the dot equals method. Dot equals returns a Boolean value if both references point to the same object. So honestly, it checks to see if two objects are the same. So I got string A equals Bob, string B equals Bob, and I say A dot equals B. This would return a true. Okay, so basically it's going to see, are they honestly having the same value inside? Are they pointing to the same information in memory? That's what we're, because those reference objects and whatnot. And those are the methods for strings and the information. I know it was a lot of information thrown at you, and we're going to do some practice on strings in the next couple of days so you guys can keep getting more comfortable with this information. I thank you for watching, and see you later, Sabers.